This week on Maker Update, a robot with a walking neck, accessories for your Q, dice that go pew, and illuminated noodles for your ears. Hey, I'm Donald Bell, and this is Maker Update, our weekly showcase of new and notable DIY projects and tips from across the internet. I hope you're doing well. We've got a great show for you. Let's get started with the project of the week. From James at JD Robotics, we've got a new and very different type of open source robot project called Stewy V2. The core concept here is a Stewart platform, which is typically a plate that can tilt in any direction based on the movement of mechanically controlled rods or actuators. In this case, the platform is Stewy's head, and the servo control joints that move the platform extend down to act as legs. So with the head and leg movement connected like this, you get this sort of crawling, head bobbing motion when it's moving around. It's not super smooth, at least not yet, but it has potential, and I think that's the most exciting part of this project. It's a solid idea that's not entirely figured out yet, and James is inviting us in to play with the design and improve how it works. In terms of electronics, you'll need 6 servos, which is pretty minimal for a project like this. All of those connect up to an ESP32 board in the head, which is where you'll also find an ultrasonic rangefinder for detecting nearby objects and a thumbstick for directly manipulating the robot. I think the most interesting and unfamiliar part of this, though, is how the rods and servos and platform all connect together. By placing bearings in the platform and encapsulating them as part of the 3D print, the hinged end of the rods can be bolted here and still allowed to twist and bend. But down at the servo end, the rods terminate in a kind of magnetic ring that rides on a threaded steel ball attached to a custom servo horn. This means you have all of these joints that are deliberately designed to break apart in a way that's easy to reset. The complex, interdependent motion of all these rods means that you're bound to move something past what it can tolerate. By having these magnetic joints, you really have permission to push the design and learn what it can take without spending hours in repair mode. I'll leave a link down in the description where you can find the full build guide, code, and bill of materials, as well as an option to buy the robot as a kit or fully assembled. Now for some news, and there's a lot to cover this week. Let's start with the bad news. On their blog, Raspberry Pi has announced yet another substantial price hike to several models of their popular line of single board computers. Like the last increase, this one is again tied directly to the skyrocketing global cost and demand for RAM. To ease the pain a little, they have introduced a new 3GB version of the Raspberry Pi 4, sitting at around $83. If you don't need the latest, fastest model, maybe that's a good fit for your project. From Arduino, we've got a new batch of products designed for the latest Uno Q board. The most notable, in my opinion, are these 2 expansion boards, the Uno Media Carrier and the Uno Breakout Carrier. Both boards are made so that you just push the Uno Q right onto a set of pass-through connectors. The Media Carrier offers connections for 2 cameras, a display, and audio input and output. The camera input conveniently uses the same 22-pin standard as the Raspberry Pi camera. The breakout board is pretty self-explanatory. It's an inexpensive way to expose every available pin on the board, routed to headers that you can quickly prototype with. And the last bit of interesting news to share is that FreeCAD version 1.1 has just been released. This free open source 3D modeling tool now includes new options for lighting, widgets, snapping, sketching, creating holes, assemblies, and more. It's nice to see an open source tool like this thriving and gaining momentum. Now for more projects, here's a fun one from Oskitone. It's a little noisemaker circuit that doubles as a random number generator. There's no code or microcontroller here. It's a combination of 3 chips, some LEDs, and some clever circuit design. I also just love Oskitone's enclosure design aesthetic. It's so chunky and playful and perfectly conveys that this is a device made for fun. And if you're looking for a practical reason to make one, it really does function as an electronic substitute for dice. So you can add one of these to your next board game night and mix things up. Another fun, clever, no-code project are these LED Noodle Earrings from snowbiscuit on Instructables. A 3D printed battery holder is the key to the whole thing. Add the LED noodle strand, a battery, and a glued-on earring stud, and you're ready to go. Because the LED noodles are typically stiff at the ends, you can just push them through the holes of the 3D printed battery holder, one end to negative and the other to positive. Simple but effective, and probably a real showstopper at night. Now for some tips and tools. On the Manafish ROV YouTube channel, there's a great guide on strategies and techniques for waterproofing your projects, even your electronics. From coatings to housings, material trade-offs, and specialty connectors, there's a ton of helpful information here. One quick takeaway is that nail polish is often a quick and effective way to coat electronics and keep moisture out. On his channel, Will Donaldson has a collection of tips for wiring and soldering up LED strip. If you're new to working with LED strip or frequently frustrated by it, the whole guide is worth a watch. But I think the best, most radical tip he offers here is to sacrifice an LED when cutting your strip into sections. If you do it right, you leave these full uncut pads to solder onto. Not only do these larger pads make soldering easier, but they lend themselves to stronger, more durable connections. For this week's DigiKey Spotlight, check out the latest video in the Another Teaching Moment series, showcasing the inherent differences between analog and digital sensors. Each technology has advantages and disadvantages that lend themselves to different measurements under different circumstances. By getting familiar with some of the basics here, you'll be better informed when shopping for your next project. Alright, and that does it for this week's show. Be sure to subscribe, leave a thumbs up, or leave a comment. A big thanks as always to DigiKey for making this show possible, and thank you for watching. I'll see you soon.